Hello everyone, welcome to my channel Chemistry by ANR. We are going to do the second law, which is law of constant proportion, and these are the law of chemical combinations. Law of constant proportion was given by Joseph Proust in the year 1779. It was given by Joseph Proust in the year 1779, and it states that a chemical compound always consists of the same elements combined together in the same proportion by mass. That means if I say that two elements are there, hydrogen and oxygen, they are forming a compound water. So water is a compound. It always consists of same two elements, hydrogen and oxygen, combined together in same constant proportion 1:8 by mass. That is, 1 part by mass of hydrogen will always combine with 8 parts by mass of oxygen. See, water is H2O. H2O is water. Now, H is to O by mass. What is the ratio? We need to know that. What is the ratio by mass? That is equal to, for that, you have to know the atomic weight of hydrogen, the atomic weight of oxygen. Atomic weight of hydrogen over here is 1. There are 2 such hydrogen, so 1 into 2. So you need to know the atomic weight or atomic mass, okay, of H. Of H is equal to 1. Of O is equal to, over here, O is equal to 16. Okay, so now I can say that 1 into 2. Why? Because atomic mass means mass of one atom of hydrogen, and here there are 2 atoms of hydrogen. So I am writing mass of one atom into number of atoms. So 1 into 2 plus oxygen, there is only one atom, so we can say 16. So this is the total atomic mass. Now over here I am finding the ratio. So what I will write? I will write is 2. Okay, so this will be equal to 2:16 by mass, which is equal to 1:8. So that is the ratio of H and O by mass in water. Okay, now this is what we can see. Now ammonia is a compound. You know, ammonia formula of ammonia is NH3. So you can say there is one atom of nitrogen, N is nitrogen, one atom of hydrogen, and it has 2 elements now. It has 2 elements. One element is nitrogen, N, and the other element is hydrogen, that is H. They are combined together in the same ratio of 14:3 by mass. Why 14:3? Because here again atomic mass of nitrogen is equal to 14, of hydrogen is equal to 1. So there are 1 nitrogen, 3 hydrogen. So I can say N:H by mass is equal to 14:3. For that reason, I hope it is clear. Now please note that the law of constant proportion is also known as law of definite proportion or law of constant composition. So there are 3 names. One is law of constant proportion, same it is law of definite proportion and law of constant composition. Now this is one question related to this concept. In an experiment, it has been found that 1.288 gram of copper oxide. Copper oxide contains two elements. One is copper and the other is oxygen. So CuO was obtained from, this much copper oxide was obtained from 1.03 gram of copper. And in another experiment, it was seen that 3.672 gram of copper oxide gave on reduction 2.938 gram of copper. So there are two experiments. In one experiment, it is saying this is the first experiment. In an experiment means this is the first experiment. Copper oxide is obtained from 1.03 gram of copper. That means in this experiment what is being done? A reaction between copper and oxygen has been done and you get a combination which is known as a compound which is known as copper oxide. So you got CuO over here. Now it is being said that in another experiment, means this is your second experiment. So in another experiment, in the second experiment, 3.672 gram of copper oxide. So copper oxide on reduction means on reaction with hydrogen. When you reduce it, this is reaction with hydrogen is known as reduction. You may not write in your exam, okay, reaction with hydrogen. You can just write on reduction. It produces this many gram of copper. So you obtain copper, how much? 2.938 gram. As a beginner of chemistry, you may not know now the entire reaction, what is happening. Okay. Now, what you have to focus on? You have to focus on the fact that in copper oxide, what is the mass of copper? What is the mass of oxygen? Is it the same in both the compounds? That you have to focus on. Now let us see how to solve it. See, in the first experiment, mass of copper. So here it has been obtained ki 1.03 gram of copper is giving 1.288 gram of copper oxide. So mass of copper is 1.03, mass of copper oxide is this. So you know copper oxide contains copper and oxygen. So if from the law of conservation of mass, I know that the mass of copper and oxygen should be equal to the mass of copper oxide, because copper and oxygen are the reactant and copper oxide is the product. So if I keep this in mind, then I should know that the mass of oxygen can be obtained if I subtract the mass of copper from the mass of copper oxide. Copper oxide is 1.288. If I subtract the mass of copper from it, I will get the mass of oxygen. So this is the mass of oxygen. I have written O. Now that is coming out to be 0.258 gram. This much calculation you have to do. Now this is mass of oxygen and mass of copper is already given. See, you can find copper is to oxygen by mass. What is the ratio? If you do it, see, copper was 1.03. So you have written 1.03 is to oxygen. You calculated and got 0.258. So when you are doing is to, you know, it always mean 1.03 by 0.258 is to 1. That means obviously if you multiply 0.258 by 1, you will get 0.258 only. So you can write this ratio in this manner to simplify it. Now when you calculate, you should be good in basic mathematical operations. Division, multiplication, addition, subtraction, you should be good in that. So when you divide 1.03 by 0.258, you will get 3.99. this you will get, is to 1. So it is 3.99 is to 1. This is equivalent to 3.99, I can say equivalent to 4. So 4 is to 1 is the ratio by mass. It is obtained from one experiment, in the first experiment. Now definite proportion means from whichever experiment you obtain, the mass of copper and oxygen should always remain fixed. So let us check in the second experiment. Mass of copper is 2.938 gram. Mass of copper oxide is 3.672 gram. So this is copper oxide, this is copper. You can subtract the mass of copper from copper oxide and you will get the mass of oxygen. So once you get the mass of oxygen, you know the mass of copper, you can always find the ratio. So the ratio is 2.938 is to 0.734. Do the same thing. That is 2.938. You divided by 0.734 is to 1. So for this you need to do this division. When you do, you will get 4 is to 1 again. So let me tell you, it comes 2.938 divided by 0.734 is coming out to be 4.002. It's coming this. So it can be written as 4 only. So this is to 1 means 4 is to 1. So in the first experiment you got ratio of copper is to oxygen to be 4 is to 1. In the second experiment also you got ratio of copper is to oxygen by mass to be 4 is to 1 again. So it is fixed. So this is, the law is hence verified. The next application, let us see. Hydrogen and oxygen combine in the ratio 1 is to 8 by mass. So hydrogen means H, oxygen means O. They combine in 1 is to 8 ratio by mass to form water. Water is H2O. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? That means if you make 3 gram of hydrogen gas to react with oxygen, what mass of oxygen gas would be required? For that you need to utilize the data. Here the data is that hydrogen is to oxygen by mass in H2O is equal to 1 is to 8. That means what? 1 gram, this is very important. This means that 1 gram of hydrogen require 8 gram of oxygen gas. 1 is to 8 means 1 gram of hydrogen gas requires 8 grams of oxygen gas. Now they are telling 3 grams of hydrogen gas will require how many gram of oxygen gas? It's plain and simple unitary method. You have to do 8 divided by 1 into 3. That means 8 into 3 only. That is 24 gram. So here the application is whether you know what is the meaning of hydrogen is to oxygen is 1 is to 8 by mass. It means 1 gram of hydrogen reacts with 8 grams of oxygen. If you multiply by 2, 2 gram of hydrogen reacts with 16 gram of oxygen. It means in this manner only. So similarly, 3 gram of hydrogen reacts with 8 into 3, 24 gram of oxygen. The next one, let's go to the next one. As many numericals you will solve, you will become confident. So try and solve numericals in your copy. When you see the video, you should always have a pen and paper in hand. Instead, I will say a pen and copy in hand. Work out on your own and find the answers. Now, when 3 gram of carbon is C, is burnt in 8 gram of oxygen is O, 8 gram of oxygen, carbon and oxygen. 11 gram of carbon dioxide is produced, so it is CO2. All are by mass because you are seeing the unit of mass, gram. What mass of carbon dioxide will be formed if 3 gram of carbon is burnt in 50 gram of oxygen? Now, if it is burned in 8 gram of oxygen, you will get 11 gram of CO2. Now, if 3 gram of carbon is burnt in 50 gram of oxygen, how many gram of CO2 is obtained? This is the first part of the question. The second part of the question says, which law of chemical combination will govern your answer? So obviously your answer will be governed by law of constant proportion or constant composition or definite proportion. You can say any one. Why? Because it is about combination of carbon and oxygen forming CO2, where carbon is an element, oxygen is an element, CO2 is a compound. Now, since carbon and oxygen combine in fixed proportion 3:8 by mass, okay, you are seeing 3 gram of carbon is combining with 8 gram of oxygen. So here 3:8 by mass to form 11 gram of CO2. Same mass of carbon dioxide will be obtained even if we burn 3 gram of carbon and 50 gram of oxygen. You know why? Because you already know that 3 gram of carbon will always require 8 gram of oxygen in order to prepare 11 gram of carbon dioxide. It will exactly require 8 gram. उसे कम दोगे तो भी नहीं, ज़्यादा दोगे तो 8 gram ही यूज होगा ना. So it will obviously produce 11 gram of carbon dioxide then also, because out of your 50 gram, it will use 8 gram only. And whatever extra oxygen is there, 50 minus 8, it will be remaining unreacted. So this question is a tricky question. That if you are supplied more, what will happen? If you are supplied more, it will always react because the proportion is same, 3:8. Now if you say that, okay, I have actually given 16 gram of oxygen. So 16 gram of oxygen, you are 8 into 2 is 16. So 3 into 2, 6 gram of carbon के साथ reaction करेगा. It will be something like that. So this is it. Next, 0.24 gram sample of compound of oxygen. Oxygen is O, boron is B, was found by analysis. So to contain 0.96 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by mass. You know what does percentage composition mean? Percentage composition actually means out of 100 part. So calculate the percentage composition of the compound by mass. So out of 100 gram of compound, out of 100 gram of the compound, how many gram of oxygen and how many gram of boron is present? So for that, what you have to do? See, mass of boron in compound is supplied. This is given. Mass of the compound is also given. These are all given. These are all given. So if you have to find the percentage of boron, this is mass percent, because by mass, you know, mass percent of an element, what does it mean? Any element, whether it is boron, oxygen, or it is hydrogen, oxygen in water, it is actually mass of that element in compound, means whichever compound you are talking of, divided by mass of the compound. That means the total mass of the compound into 100. Always remember this formula, that if you are finding mass percent of an element, you are always doing mass of the element in the compound divided by mass of the compound into 100. So here mass of the element means mass of boron, because you are finding percentage of boron in the compound. So mass is given 0.096 divided by, see, mass of the compound is given, so divided into 100. Okay, so when you solve this, you will get 40. Okay, so again you have to be good in basic mathematical functions, how to solve numericals based on decimals and all. So maths is required in every subject, so pay attention over there, work out maths. Now mass of oxygen in the compound, see, mass of oxygen in the compound, let us see this one is supplied, right? So we are getting this because it's given. Mass of the compound is also given. Now you apply this formula that I gave you now and find percent of oxygen. That means mass of oxygen in the compound. So it's given mass of oxygen in the compound. Divide by total mass 0.24 into 100. You will get 60. Since it is out of 100, it is called 60%. And boron is 40%. If you mark, you will see, since it is percent, the total should be 100. So 40 plus 60 is equal to 100. Means your answer is correct. Some of the students say, ma'am, if I calculate the percent of boron by mass, and I get it to be 40%, then I can say percent of oxygen will be equal to 100 minus 40%, which is equal to 60%, and this is exactly correct. But there is only one problem, in case you do any mistake in the calculation in the previous percentage which you are using later on, then both the answer comes out to be wrong. But if you are correct in the first step, then automatically you can do less of calculation, do 100 minus this and get the second one. So similarly, you can calculate the mass percent, say, of hydrogen in water, mass percent of oxygen in water. This also you can do. So in the next module, we will do Dalton's atomic theory. But here let me show you. Suppose you want to calculate mass percent of hydrogen in H2O. So you have to find the molecular mass of H2O. So molecular mass of H2O क्या है? Molecular mass of H2O, actually the one molecule of H2O, see, one molecule of H2O contains what? Contains 2 atoms of H and 1 atom of O. From the molecular formula you can see H2O, 2H, 1O. So you can say molecular mass will be equal to 2 into mass, I will say 2 into mass of H atom, because mass of one H atom into 2 plus mass of O atom. Why? Because there is only one oxygen, right? So mass of H atom is 1 gram. So here you will get 2. 1 gram, so here you get 2, plus mass of O atom is 16. So you get 18 gram is the mass of the compound H2O. Now if I want to find the mass percent of H in H2O, what will I do? I will use this formula which I have just discussed, mass of that element in the compound. So H mass, how much of the mass is present? 2 gram. Why? Because there are 2H and mass of 1H is 1 gram. So that is equal to 2 gram divided by total mass. total mass of all the elements over here, that is 18, that is the mass of the compound, into 100. Right? So whatever value you will get over here, that is 100 by, you are going to get 9, because whatever value you will get, that will be the mass percent of H in H2O. Now you can find the mass percent of O by subtracting that value from 100. I hope the concept is clear. So check whether you know law of definite proportion, whether you are able to solve the numericals which I have shown you, whether you are able to calculate mass percent, and you are able to analyze what does ratio of the element by mass mean. So till then, bye all of you. See you in the next module.